When we step out into the garden on a clear, moonless night, and we look up, we are met with a sight that has captivated our species for as long as we have walked the earth. Above us stretches the velvet canopy of the cosmos, dusted with the diamond dust of 1,000 stars. It is a scene of immense tranquility. The constellations hang static and silent, frozen in their eternal poses. The planets glow with a steady, unblinking resolve. To our human eyes, the night sky appears to be a singular, unified moment. We feel as though we are seeing the universe exactly as it is, right now, in this very second. But this feeling is an illusion, a magnificent, comforting, and profound trick of the light. Tonight, we embark on a journey that will challenge our most basic perception of reality. We are not looking at a ceiling. We are peering into a deep, vertical tunnel. We are looking at a history book where the pages are made of vacuum and the ink is made of photons. We are about to discover that the simple act of lifting your gaze to the heavens is, in the most literal sense of the physics, an act of time travel. To understand this paradox, we must first understand the messenger, light. Everything we see, from the book in your hands to the mountain on the horizon, is visible only because light has traveled from that object to your retina. On Earth, in the cramped confines of our daily lives, this travel time is so fast that it appears instantaneous. If you switch on a lamp in the corner of the room, the light floods the space immediately. There is no perceptible delay between the flick of the switch and the illumination of the wall. This immediacy has trained our brains to believe that seeing is simultaneous with being. If we see it, it is happening now. But the universe is not a living room. The scales of the cosmos are so vast that they break our terrestrial intuition. Light is fast, incredibly fast, but it is not infinite. It has a speed limit. It travels at roughly 300,000 kilometers per second. That is 186,000 miles every single second. It is a speed that allows a photon to circle the Earth 7.5 times in the duration of a single heartbeat. To us, that sounds like instantaneity. But to the universe, which measures distance in billions of light years, light is a slow, plodding courier. It takes time to cross the void. And because it takes time, the image it carries is always, inevitably, out of date. The night sky is a mosaic of different times. It is a collage of the past. When you look at the moon, you are not seeing the moon as it is. You are seeing the moon as it was 1.3 seconds ago. When you look at Jupiter, you are seeing it as it was 40 minutes ago. And when you look at the stars, you are looking back through decades, centuries, and millennia. The sky is a time machine, and tonight we are going to learn how to operate it. Let us begin our exploration right here, on the surface of our own world, and move slowly outward. Imagine standing on a shoreline at night. You see a lighthouse flashing in the distance. The beam sweeps across the water and hits your eye. You register the flash. Strictly speaking, you are seeing the lighthouse as it was a tiny fraction of a millisecond ago. The delay is negligible. But now, imagine that lighthouse is moved to the moon. The moon is our closest celestial companion. It orbits at an average distance of 384,000 kilometers. It is a stone's throw in cosmic terms, yet the gap is wide enough to introduce the first noticeable lag in our reality. Light, leaving the cratered, gray surface of the moon, must swim through the vacuum of space for 1.3 seconds before it strikes the atmosphere of Earth. This means that we never ever see the moon in the present. We are always living just over a second behind it. If a massive asteroid were to strike the moon this very instant, throwing up a cloud of dust and shattering the silence of the lunar regolith, we would not know. We would look up and see the peaceful silver disk. We would continue to admire its beauty for 1.3 seconds. Only then would the image of the destruction arrive. Only then would our reality catch up with the moon's history. This delay is small, yes. A second is a heartbeat, a breath. But it is the first crack in the illusion of now. It proves that now is a local phenomenon. Now is a bubble that surrounds you, and the further you look, the further you drift from it. Let us extend our gaze further. Beyond the moon, the darkness deepens. The distances stretch out into the millions of miles. We encounter the planets. Consider Mars, the red planet. It wanders through our night sky, a bright, rust-colored spark. Depending on where Earth and Mars are in their respective orbits, the distance between us varies wildly. But on average, it takes light, or radio signals, about 12 to 20 minutes to cross the Gulf. This reality has profound implications for our robotic explorers. When the Perseverance rover lands on the surface of Mars, the engineers at NASA are not driving it with a joystick in real time. They cannot. If they see a cliff approaching on their screens and they hit the brakes, that command will take 20 minutes to arrive. By the time the rover receives the order to stop, it has already fallen over the edge 20 minutes ago. The Mars we see in the sky is a ghost of the immediate past. We are watching a recording that is 20 minutes old. Move further out, to the realm of the giants, Jupiter, Saturn. When you look at Saturn through a backyard telescope, you see the magnificent rings. They look solid, perfect, immutable. The light reflecting off those icy particles left the planet over an hour ago. You are seeing Saturn as it was when you were eating your dinner. If the rings were to suddenly vanish, if some cosmic magician waved a wand and erased them, you would still see them for another hour. You would be admiring a structure that no longer exists. This concept, the persistence of the image after the object is gone, is key to understanding the deep sky. The universe is populated by ghosts. Light is a stubborn messenger. It insists on delivering its message even if the sender has died. But the planets are merely our neighbors. They are in the same room as us, cosmically speaking. The true power of the time machine reveals itself when we look at the stars. The stars are suns. They are roaring nuclear furnaces burning with unimaginable fury. But they are so distant that their light is reduced to a pinprick. Consider Sirius, the dog star. It is the brightest star in our night sky. It blazes with a blue-white intensity that pierces the winter gloom. Sirius is 8.6 light-years away. Light-year is a confusing term. It sounds like a measure of time, but it is a measure of distance. It is the distance that light travels in one Earth year, about 9 trillion kilometers. So, when you look at Sirius tonight, the light hitting your retina left the surface of that star 8.5 years ago. You are seeing the star as it was when you were 8 years younger. Think back to where you were 8 years ago. What were you doing? Who were you with? The light you are seeing now was born in that moment. It has been traveling across the cold, empty void while you lived your life. It crossed the interstellar dark while you changed jobs, moved houses, fell in love, or suffered loss. And only now, tonight, does it finally finish its journey by colliding with your eye. Every star in the sky has a different lag time. Betelgeuse, the red giant in the shoulder of Orion, is roughly 640 years away. When you look at that ruddy orange point of light, you are looking at light that left the star in the Middle Ages. While that light was traveling, empires on Earth rose and fell. The Renaissance happened. The Industrial Revolution happened. The Space Age began. And all the while, those photons were just streaming silently through the vacuum, carrying the image of a medieval star to modern eyes. Deneb, another bright star in the Summer Triangle, is over 2,000 light-years away. Its light began its journey before the Roman Empire reached its peak. When you look up at the night sky, you are not looking at a flat canvas. You are looking down a deep well of time. Sirius is near the top of the well. Betelgeuse is deeper. Deneb is deeper still. Your eye is flattening all this depth into a single 2D image, but the mind can expand it back out. The mind can perceive the depth. This realization brings with it a sense of profound isolation, but also a sense of connection. We are isolated because we can never touch the now of the universe. We are forever trapped in our own local bubble of time. We can never know what is happening right now on Betelgeuse. We can only know what happened 6 centuries ago. But we are connected because the light bridges the gap. The history of the universe is constantly washing over us. We are being bathed in the past. The night sky is a museum. Imagine walking through a museum where the exhibits are not statues or fossils, but live windows into different eras. Window A shows you the year 2016, Sirius. Window B shows you the year 1380, Betelgeuse. Window C shows you the year 100 BC, Deneb. And you can see them all simultaneously. This is the chaotic, beautiful chronology of the heavens. Let us consider the mechanism of this journey, the photon. A photon is a tiny packet of energy. It has no mass, and according to the strange laws of relativity, a photon experiences no time. From the photon's perspective, the journey is instant. It leaves the star and hits your eye in the same moment. But from our perspective, the observer, the journey is long and perilous. The space between the stars is not truly empty. It is filled with thin clouds of dust and gas. The photon must navigate these obstacles. If it hits a dust grain, it is absorbed. It dies. Its journey ends in the cold dark, unseen by anyone. The light we see is the survivors. The stars you see tonight are the lucky ones, the photons that managed to dodge every obstacle for hundreds of years, threading the needle through the interstellar medium, traversing the vastness of the solar system, penetrating the thick blanket of Earth's atmosphere, and finally entering the tiny aperture of your pupil. It is a miracle of probability. And what happens when it hits your eye? It strikes the retina. It triggers a chemical reaction. An electrical signal is sent to your brain. And in that moment, the photon dies. It gives up its energy to create a sensation in your mind. You are the final destination of a journey that lasted centuries. You are the tomb of ancient light. There is a soothing quality to this old light. In our modern world, we are obsessed with the new, the instant, the breaking news, the live feed. We are constantly anxious about what is happening right now. but the sky offers an escape from the tyranny of the present. When you look at the stars, you are looking at old news. The light from the Pleiades cluster is 400 years old. Whatever chaos is happening there right now, we won't know about it for 4 centuries. For us, the Pleiades are calm, stable, beautiful. The delay acts as a buffer. It filters out the urgency. The universe we see is always settled. The explosions have happened, the stars have formed, the history is written. We can relax in the certainty of the past. There is no breaking news in astronomy. There is only arriving news. Imagine the light as a letter written by a star on the day you were born. It was sealed in an envelope of speed, posted into the mailbox of the void. And tonight, you opened it. The message is simple. I am here, I am burning, I am part of the light. As we gaze deeper, the time machine takes us back to epochs before humanity existed. The Andromeda Galaxy, a fuzzy patch of light visible to the naked eye on a dark night, is 2.5 million light-years away. The light you see from Andromeda left those stars when our ancestors were just learning to use stone tools. Homo habilis walked the plains of Africa. That light has been traveling while the ice ages came and went, while civilizations rose in Mesopotamia, Egypt, and China, while wars were fought and peace was made. All of human history fits inside the travel time of that single beam of light. And yet to your eye, it is just a faint smudge, a quiet neighbor. This perspective shrinks our worries. It places our frantic short lives against the backdrop of deep time. If the light from the nearest galaxy is older than our entire species, then our daily troubles are truly fleeting. The sky demands humility, but it also offers a strange kind of immortality. Just as we look back at the stars, imagine an observer on a distant planet looking back at us. If they are 65 million light-years away, and they have a telescope powerful enough to see the surface of Earth, they would not see us. They would not see cities or highways. They would see the dinosaurs. They would see a lush, green, tropical world unaware of the impending doom. Our past is still out there. It is radiating away from Earth at the speed of light. The image of you as a child playing in the sun, that image is not gone. It is simply traveling. It is currently passing a star some 20 or 30 light-years away. In the universe, nothing is ever truly lost. It is just distant. The history of everything that has ever happened is expanding into the cosmos in a sphere of light. The universe remembers. So, as you prepare to rest tonight, let the walls of your room dissolve. Imagine the ceiling opening up to reveal the great time machine. You are not lying in a dark room. You are lying in the center of a vast sphere of history. Above you are the lights of the Middle Ages. Beyond them, the lights of antiquity. Beyond them, the lights of the prehistoric dawn. The darkness is not empty. It is full of time. The finite speed of light is not a limitation. It is a gift. It allows us to see where we came from. It allows us to see the baby photos of the universe. Without the delay, the sky would be a blinding flash of the present. We would be overwhelmed. But with the delay, the sky is a story. A story that unfolds slowly, night after night. A story that invites you to look back, to reflect, and to wonder. In the coming chapters, we will travel to specific destinations in this history book. We will visit the sun, the nearest stars, and the ancient galaxies. We will trace the journey of the light, step by step. But for now, simply accept the premise. You are a time traveler. Your highs are the portals, and the night sky is the destination. Let the weight of the centuries press gently on your eyelids. The past is a heavy, comfortable blanket. Wrap yourself in the starlight and drift. The light has traveled a long way to find you. Let it arrive. Let it rest. Sleep in the history of the light. We have established that the sky is a history book. When we look up, we are not seeing the universe as it is, but as it was. This phenomenon relies entirely on a single, fundamental constant of nature, the speed of light. In the equations of physics, it is denoted by the letter I. It is a number that governs the flow of reality itself, approximately 300,000 kilometers per second. To our human minds, accustomed to the speeds of cars, airplanes, or even sound, this number is abstract. It feels infinite, but it is finite. It is a rigid, unbreakable barrier. Tonight, we will explore this limit. We will peel back the layers of causality to understand why the universe has a speed limit, what it feels like to be a photon racing against the clock, and why this delay is the only reason we can make sense of the cosmos at all. Let us begin with a thought experiment. Imagine a universe where light is instantaneous, a universe where Zeit is infinity. In such a world, when a star explodes in a distant galaxy, we would see it the exact moment it happens. The information would teleport across the void. There would be no history in the sky. Looking deep into space would not mean looking back in time. It would just mean looking at more of the now. This sounds convenient, but it would be catastrophic for our understanding of origins. If light were instant, we could never see the Big Bang. We could never see the formation of the first galaxies. The past would be invisible, lost forever the moment it passed. The delay of light is what allows us to be archaeologists. It preserves the strata of time. But why is there a limit? Why 300,000 kilometers per second? Why not 1,000,000? Why not 10? The answer lies in the fabric of space-time itself. According to Einstein, mass and energy are interchangeable. As an object moves faster, it gains energy. As it gains energy, it effectively gains mass. It becomes heavier. To push it faster, you need more energy. As you approach the speed of light, the energy required becomes infinite. To accelerate a single baseball to the speed of light would require more energy than exists in the entire universe. Therefore, nothing with mass can ever reach the speed limit. We are forever trapped below the ceiling. But light is special. The photon has no mass. It weighs nothing. Because it has no mass, it does not need to accelerate. It is born at top speed. The moment a photon is created in the heart of a star or the filament of a light bulb, it is already moving at. It cannot go slower. It cannot go faster. It is locked to the speed limit of the cosmos. Let us adopt the perspective of the photon. Imagine you are a particle of light. You have just been forged in the nuclear furnace of the sun. You have spent 1,000,000 years fighting your way out of the dense core, a journey we will explore later, and you have finally broken the surface. You are free. The vacuum of space stretches before you. You rush forward. From your perspective, the universe is strange. Because you are moving at the speed of light, time stands still. For you, the journey takes 0 seconds. You leave the sun and hit the earth in the same instant. But for us, the observers watching you, your journey is a saga. We watch you cross the emptiness. 1 second. You have traveled 300,000 kilometers. You are already past the orbit of the moon, if it were there. 1 minute. You are 18 million kilometers away, a tiny speck of pure energy racing through the dark. 8 minutes and 20 seconds. You slam into the Earth's atmosphere. The speed limit dictates the rhythm of the conversation between the stars. It is a slow, majestic dialogue. If the sun were to suddenly vanish, if it were simply deleted from reality, we would not know. The Earth would remain in orbit around nothing. The plants would continue to photosynthesize. The beachgoers would continue to tan. For 8 minutes and 20 seconds, we would live in a world that no longer exists. We would orbit a ghost. We would be bathed in phantom light. Only when the last photon, the one emitted just before the deletion, arrived would the darkness fall. Only then would gravity let go, and the Earth fly off in a straight line. We are protected by the delay. This delay scales up dramatically. Consider the Voyager 1 spacecraft. It is the furthest human-made object from Earth, currently drifting in interstellar space over 24 billion kilometers away. It sends a radio signal back to NASA, a faint beep. That signal travels at the speed of light. It takes 22 hours to reach us. If Voyager hits a piece of dust and breaks, we won't know until tomorrow. This latency makes the universe feel lonely. It creates a sense of isolation. Every star, every planet, every spacecraft is alone in its own time zone. There is no universal now. Einstein proved that simultaneity is relative. Two events that happen at the same time for one observer might happen at different times for another observer, depending on how fast they are moving or how far away they are. The universe is not a single clock ticking for everyone. It is a collection of billions of individual clocks, all ticking at their own rates, separated by the lag of light. But there is beauty in this isolation. Because light takes time to travel, the night sky is deep. It has texture. If light were instant, the sky would be flat. But because light is slow, the sky is a tunnel. When we look at the Milky Way, that band of cloudy light stretching across the dark, we are looking at the rim of our own galaxy. The stars on one side of the band are a few thousand light years away. The stars on the other side are tens of thousands of light years away. We are seeing the galaxy not as a snapshot, but as a smear of time. We see the near edge as it was recently, and the far edge as it was in the distant past. We are seeing a temporal cross-section. It is like looking at a crowd of people, but the people in the back row are children, and the people in the front row are adults, even though they were all born in the same year. The distance changes their age in our eyes. Let us reflect on the sensory experience of this speed. Close your eyes for a moment. Imagine a pulse of light leaving a star. It travels through the vacuum. It is silent. There's no sound in space. It passes gas clouds. It passes rogue planets drifting in the dark. It is a wave, an oscillating field of electricity and magnetism. Up and down, left and right. It vibrates through the cosmos. It never slows down. It never gets tired. It can travel for 10 billion years and arrive with the exact same speed as the day it was born. but it spreads out. As it travels, the sphere of light gets bigger, the photons get further apart, the light gets dimmer. This is why distant stars are faint, not because the light is old or tired, but because it is diluted. Your eye is a bucket catching the rain of photons. From a distant star, the rain is a drizzle, one photon every few seconds. Your eye has to work hard to assemble an image from such a sparse signal. This is why we need telescopes. They are bigger buckets. They catch more rain. When we look through a telescope, we are not just magnifying the image. We are brightening it. We are collecting more of the history. The speed of light also defines the observable universe. The universe began 13.8 billion years ago. This means that the furthest light we can possibly see has traveled for 13.8 billion years. Any light coming from further away simply hasn't had enough time to reach us yet. It is still on its way. There is a horizon, an edge of time. Beyond that horizon, there are likely more galaxies, more stars, more wonders. But they are hidden from us by the speed limit. We are locked in a bubble of light. Every year, the bubble gets a little bigger. Every year, light from 1 light year further away finally arrives. We are slowly unwrapping the universe. But the universe is also expanding. Space itself is stretching. This creates a race. The light is trying to reach us, but the space between us and the source is growing. For very distant galaxies, the space is stretching faster than the light can travel. The light is like a runner on a treadmill that is moving too fast. It will never reach us. These galaxies are disappearing from our view. They are slipping over the cosmic event horizon. This adds a layer of melancholy to the night sky. The sky is a time machine, yes, but it is a machine that is slowly losing its data. The distant past is being erased by the expansion. We are living in a privileged time. We can still see the ancient light. Billions of years from now, the sky will be darker. The distant galaxies will have faded away. So, when you look up tonight, cherish the view. You are seeing a universe that is rich, connected, and full of history. Let us bring this back to the personal. The speed of light is the speed of cause and effect. Nothing can influence you faster than light. If a disaster happens in the center of the galaxy, we have 26,000 years of safety. The delay is a buffer zone. It gives us space. It also means that everything you see is a memory. Even when you look at the face of a loved one across the dinner table. The light reflects off their face and travels to your eye. It takes a few nanoseconds. Technically, you are seeing them in the past. You are never truly with someone in the exact same moment. We are all trapped in our own tiny time bubbles, reaching out across the delay. But the delay is so small, it feels like unity. It is only when we look at the stars that the delay becomes palpable. The stars teach us patience. They teach us that information takes time to travel. That understanding takes time to arrive. The light from Polaris, the North Star, has been traveling for over 400 years. It left the star when Shakespeare was writing his plays. "I am constant as the northern star," he wrote. And as we look at it tonight, we receive that constancy, a beam of light that bridges the Elizabethan era and the modern era. A thread of continuity. As you settle into the darkness of your room, think of the light in the room. When you turn off the lamp, the room goes dark instantly. Or so it seems. In reality, the last photons bounce around the room for a few nanoseconds before being absorbed by the walls. For a tiny, imperceptible moment, the room is full of old light. And then, quiet. The speed of light is the heartbeat of the cosmos. Tick-tock. 300,000 kilometers. It is the metronome that keeps the universe in order. Without the limit, everything would happen at once. With the limit, things happen in sequence. There is a story. There is a beginning, a middle, and an end. And you are the reader. Relax into the rhythm of the speed limit. You do not need to be instant. You do not need to be everywhere at once. Even the light takes its time. Even the fastest thing in the universe has to wait. Let that permission wash over you. If the light can take 1,000,000 years to get somewhere, you can take 8 hours to sleep. The universe will wait for you. The history book will still be open tomorrow night. The stars will still be sending their ancient signals. Drift in the delay. Rest in the lag. Sleep. The night has passed. The earth has turned on its axis, carrying us out of the shadow and back toward the light. We open our eyes to the morning. We see the golden glow spilling across the horizon, painting the clouds in hues of apricot and violet. We feel the gentle warmth on our skin, a sensation of immediate comfort that wakes the world from its slumber. The birds sing, the flowers open, and the day begins. It feels like a fresh start. It feels new. But by now, we know the truth. This morning light is not new. It is a traveler that has just completed a frantic final sprint across a gulf of space so vast that it defies imagination. And more than that, it is a messenger carrying energy that was forged before human civilization began. Tonight, in Chapter 3, we turn our gaze to the sun. We will trace the epic odyssey of a single photon of sunlight. We will discover that the journey does not begin at the surface of the star, but deep within its crushing heart. We will witness the random walk, a struggle that lasts for millennia, and the final, silent 8-minute flight across the void that brings the life-giving energy to our doorstep. We are about to learn that the sun on your face is the touch of prehistoric history. To understand the journey, we must first understand the destination, the sun. To the naked eye, it is a perfect, blinding disk. To the ancients, it was a god, a chariot of fire driven across the sky. But to the physicist, it is a machine, a colossal, roaring engine of nuclear fusion held together by its own immense gravity. The sun is not a solid object. It is a ball of plasma, gas that is so hot that the electrons have been stripped from their atoms. It is 330,000 times more massive than the Earth. If the sun were a hollow sphere, you could fit 1.3 million Earths inside it. It is the tyrant of our solar system, holding 99.8% of all the mass in its grip. Everything else, Jupiter, Saturn, Earth, the asteroids, is just leftover debris, dust motes dancing around the master. But the surface we see, the photosphere, is merely the skin. The true drama happens deep inside. Let us travel inward, through the turbulent convection zones, through the radiative zone, down to the core. Here, the temperature is 15 million degrees Celsius. The pressure is 340 billion times the atmospheric pressure of Earth. The density is so high that the hydrogen gas is compressed into a soup of metallic heaviness. In this hellish crush, atoms are smashed together. Hydrogen nuclei, protons, are forced to fuse. They merge to become helium, and in that merger, a tiny fraction of their mass is lost. It is converted directly into energy, according to Einstein's famous equation, E hat mc $2. That energy is released as a photon, a particle of light. This is the birth of the sunlight you see today. But this photon is not the gentle yellow light of a summer afternoon. It is a gamma ray, a violent, high-energy packet of radiation that would kill you instantly if you were exposed to it. And it is trapped. This is the beginning of the long struggle. We often say that light takes 8 minutes to get from the sun to the Earth. This is true for the journey through space, but it is not true for the journey through the sun. The core is crowded. It is packed tight with protons and electrons. The newly born gamma-ray photon travels only a tiny fraction of a millimeter before it crashes into a charged particle. It is absorbed and then immediately re-emitted, but it is re-emitted in a random direction. It might go forward, it might go backward, it might go sideways. It travels another fraction of a millimeter. Crash, absorbed, re-emitted, random direction. It moves again. Crash. This is called the random walk, or the drunkard's walk. Imagine a person trying to leave a crowded room, but they are blindfolded and spun around after every single step. They would stagger back and forth, retracing their steps, moving in circles. It would take them an eternity to find the door. For the photon, the room is the size of a star. It bounces, billions of times a second. It fights its way outward, inch by agonizing inch. Sometimes it gets lucky and moves toward the surface. Sometimes bad luck sends it plunging back toward the core. How long does it take to escape? Estimates vary, but physicists calculate that it takes between 100,000 and 1 million years for a photon to travel from the center of the sun to the surface. Let that sink in. The light hitting your eye this morning was created when early humans were still living in caves. It began its journey when mammoths walked the tundra. It was bouncing around inside the sun during the ice ages. It was struggling to get out while civilizations rose and fell on Earth. While the pyramids were being built, this light was halfway to the surface. While Columbus was sailing the ocean, this light was in the outer convection zone. The energy is ancient. It is a fossil of a nuclear reaction that happened in prehistory. But as it travels outward, it changes. With every collision, the photon loses a little bit of energy. It cools down. It starts as a gamma ray, then it becomes an X-ray, then ultraviolet. By, say, the time it finally reaches the surface, the photosphere, it has been tamed. It has shed its lethal fury. It has become visible light. Yellow, green, red, blue. It is ready to leave. Now the sprint begins. The photon breaks the surface. The density of the gas drops to almost zero. The obstacle course is over. The prison door is open. For the first time in 100,000 years, the photon has a clear path. It accelerates, or rather, it continues at its constant speed, but without interruption, into the vacuum. The clock starts. Distance to Earth, 150 million kilometers. Speed, 300,000 kilometers per second. Estimated travel time, 8 minutes and 20 seconds. Let us ride along with this packet of light. Minute 1. We are leaving the corona, the sun's tenuous outer atmosphere. It is a ghostly halo of superheated plasma, visible only during an eclipse. We pass through it in seconds. The sun behind us is a wall of fire, receding fast. The solar wind, a stream of charged particles, is blowing around us, but we are faster. We leave the particles in the dust. Minute 3. We cross the orbit of Mercury, the innermost planet, a scorched, cratered rock. If you were standing on Mercury, the sun would look 3 times larger than it does from Earth. The light is intense here, stripping the surface, baking the rock. But we fly past. We are not destined for Mercury. Minute 6. We pass the orbit of Venus, the clouded planet. Venus is wrapped in a thick blanket of carbon dioxide. It reflects 70% of the light that hits it. To us, looking back from Earth, Venus is a brilliant jewel, the morning star. But for the photon that hits Venus, the journey ends in a haze of sulfuric acid clouds. It is absorbed by the heat, trapping the planet in a runaway greenhouse effect. We fly past. We are not destined for Venus. Minute 8. A pale blue dot appears ahead. Earth. It is small, fragile, suspended in the black. It grows larger. We can see the white swirls of hurricanes, the brown of the continents, the deep sapphire of the Pacific Ocean. We are almost there. 8 minutes, 20 seconds. We hit the atmosphere. The vacuum ends. We encounter air, nitrogen, oxygen. The atmosphere is a filter. It is a prism. The blue photons in our packet are scattered. They bounce off the nitrogen molecules and spread out across the sky, turning the black ceiling into a dome of azure blue. This is Rayleigh scattering. It is why the sky is blue. The red and yellow photons punch through. They are less affected. They stream down toward the surface. And finally, impact. The photon strikes a green leaf in a forest. It hits a molecule of chlorophyll. Its energy is absorbed, triggering a chemical reaction that turns water and carbon dioxide into sugar. It becomes food. It becomes the wood of the tree. Or the photon strikes the ocean. It warms the water, evaporating a molecule of H2O, which rises to form a cloud, which eventually rains on the crops. Or the photon strikes your skin. You are sitting on a park bench. You close your eyes. You feel the heat. That heat is the end of the story. The energy that was fused in the core during the Stone Age, that wandered the radiative zone for 100 millennia, that flew across the void for 8 minutes, has finally found its home. It has become the warmth on your cheek. This connection is intimate. We are physically touching the star. The light is not just a picture. It is a transfer of substance. But remember the delay. The sun you see in the sky is the sun of 8 minutes ago. If the sun were to explode right now, we would have 8 minutes of ignorance, 8 minutes of peace. The birds would keep singing. The solar panels would keep generating power. The beach would stay warm. We are living in the echo of the star. This astronomical unit, the distance between Earth and Sun, is the yardstick of the cosmos. When astronomers talk about distances, they talk in AUs. Jupiter is 5.2 AUs away, 43 light minutes. Pluto is 40 AUs away, 5.5 light hours. The Voyager spacecraft is 160 AUs away, 22 light hours. It defines our local neighborhood. It defines the size of our now. But the concept of 8 minutes is also a measure of safety. We are in the Goldilocks zone, not too close, not too far. If we were at 3 light minutes, Mercury, the oceans would boil. If we were at 40 light minutes, Jupiter, the oceans would freeze. 8 minutes is the distance of liquid water, the distance of life. There's a profound realization when you watch a sunset. Imagine standing on the beach as the red disk of the sun dips below the water. The light is bending through the thickest part of the atmosphere, turning red and orange. You watch the last sliver disappear. The sun has set, you say. But in reality, the sun set 8 minutes ago. Geometrically, the sun is already well below the horizon. You are looking at a mirage, a ghost image projected above the curve of the Earth by the bending of light and the delay of time. We are always chasing the past. Even the gravity has a delay. The Earth is orbiting the position of the sun as it was 8 minutes ago. Technically, in general relativity, velocity terms cancel this out so orbits are stable, but the information of gravity travels at sa. The entire solar system is a dance of delayed signals, a choreography of lag. But nature handles it perfectly. The lag is built into the system. It is the rhythm of the dance. As you rest tonight, bring the image of the sun into your mind. We have spent the first leg of our journey in the warmth of the local hearth. We have traced the light of the sun, a journey of 8 minutes, and found comfort in the immediacy of our own solar system. Here, the planets are neighbors. The lag in communication is measured in minutes or hours. It is a delay, yes, but it is a manageable one. It allows for a conversation. But tonight, we must leave the nest. We must turn our backs on the sun, push past the icy sentinels of Neptune and Pluto, and drift out into the true abyss. We are crossing the Great Divide, the space between the stars. Tonight, our destination is the nearest star system to our own, Alpha Centauri, specifically the faint red dwarf known as Proxima Centauri. It is a name that sounds close. Proxima means next, but the distance is a chasm that defies human comprehension. We are about to learn that in the galaxy, next door is not a walk across the street. It is a journey of 4 years at the speed of light. We are peering into a mirror that shows us the world as it was 4 years ago. To understand this leap, we must first appreciate the emptiness. When we look at diagrams of the solar system in textbooks, or even in our minds, we see the planets spaced out, and then the next star just a bit further to the right. But the scale is misleading. If the sun were a grapefruit in London, and the Earth were a grain of sand a few meters away, where is the next star? It is not in the next room. It is not in the next town. If the sun is a grapefruit in London, Proxima Centauri is a cherry in Los Angeles. Between London and Los Angeles, there is nothing. No other grapefruits, no other cherries, just thousands of miles of empty ocean and continent. This is the reality of the interstellar medium. As we travel away from the sun, the light fades. The solar wind, that stream of particles that filled our solar system, dies down. We cross the heliopause. The magnetic bubble of our home protects us no longer. We enter the deep silence. Here, the density of matter drops to almost zero, a single atom of hydrogen in a cubic centimeter of space. It is a vacuum more perfect than anything we can create in a laboratory on Earth. And it is dark. The sun is just another star now, a very bright one, yes, but a point of light, not a disk. We are in the void. We travel through this void for not minutes, not hours, but years. Light, moving at 300,000 kilometers per second, takes 4 years and 3 months to cross this gap. 4 and 24 light years. Let us contextualize this time, 4 years. It is the length of a high school education. It is the term of a presidency. It is the time it takes for a newborn baby to learn to walk, talk, and form complex sentences. The light hitting your eye tonight from Proxima Centauri left that star 4 years ago. Think back to where you were 4 years ago. Perhaps the world was a different place, different worries, different joys. You were a slightly different person. The photons arriving now are carrying the news of that time. If you were to look at Proxima Centauri through a telescope and see a giant flare erupting from its surface, you might say, "Look, it's exploding." But you would be wrong. It exploded 4 years ago. The flare is already over. The star has already calmed down. The atoms that were ejected have already traveled billions of miles. We are watching a rerun. Let us arrive at the destination, the Alpha Centauri system. It is not one star, but 3, a triple ballet. First, there are the 2 bright stars, Alpha Centauri A and Alpha Centauri B. They are the pointers in the southern sky. Alpha Centauri A is a yellow star very similar to our Sun. Same size, same temperature. Alpha Centauri B is a slightly smaller orange star. They orbit each other in a slow, majestic waltz, completing a turn every 80 years. They are close enough that if you lived on a planet around one, the other would be a second sun, bright enough to read by, banishing the night. But drifting far away from this central pair, about 1 trillion miles away, is the third member, the outcast. Proxima Centauri. This is the one that is truly closest to us. It sits slightly closer to Earth than the main pair. But despite being our nearest neighbor, you cannot see it with the naked eye. It is too small, too dim. It is a red dwarf. It has only 12% of the mass of the Sun. It is barely larger than Jupiter. It glows with a faint, ruddy embers light. If the Sun is a lighthouse, Proxima is a dying candle. And yet this little red ember is the center of our attention, because orbiting this dim star is a world. Proxima Centauri b. Discovered in 2016, this planet is roughly the size of Earth, and it sits in the habitable zone. Because the star is so cool, the habitable zone is tucked in very close. The planet orbits Proxima every 11 days. It is huddled against the fire for warmth. Time, 3s. It is likely tidally locked, just like the planets we explored in previous stories. One side facing the red sun, one side facing the dark. But here is the mind-bending reality of the time machine. Imagine there is a civilization on Proxima b. Imagine they have powerful telescopes. And imagine they are looking at Earth right now. What do they see? They do not see you sleeping in your bed tonight. They see Earth as it was 4 years ago. They see the weather patterns of 4 years ago. They see the radio signals we broadcast 4 years ago. They are watching our past. And if they decide to send a message, a radio signal saying hello, that signal travels at the speed of light. It takes 4 years to cross the void. So 4 years from now, we receive a message, hello. We get excited. We send a message back, hello, we are here. That message takes another 4 years to return to them. The round-trip time for a conversation is roughly 9 years. Imagine trying to have a conversation with a 9-year delay. How are you? 9 years later. I'm fine. How are you? 9 years later. I'm good. In the time it takes to exchange pleasantries, a child has grown up and left home. This tells us something profound about the universe. It is not built for conversation. It is built for monologue. The stars shout into the void, but they rarely get an answer in time for it to matter. We are isolated by the lag, but 4.2 light-years is also a tantalizing distance. It is the edge of possibility. In the vastness of the cosmos, 4 light-years is nothing. It is right next door. If we can't reach Proxima, we can't reach anything. This has inspired the Breakthrough Starshot project. The idea is to build tiny spacecraft, chips the size of a postage stamp, attached to light sails. We would use powerful lasers on Earth to push these sails, to accelerate them to 20% of the speed of light. At that speed, they could reach Proxima Centauri in 20 years. Imagine that, a human-made object reaching another star within a human lifetime. The probe would fly past Proxima b. It would take pictures. It would taste the atmosphere. And then it would beam the data back. The data travels at the speed of light. So, 20 years to get there, plus 4 years for the signal to come back. 24 years. It is a long wait, but it is a finite wait. It represents the very limit of our reach. But for now, we only have our eyes. When you look at the southern sky, if you are in the southern hemisphere, you see Alpha Centauri as a single bright star. Your eye cannot separate A and B. They merge into one point of light. And Proxima is invisible. There is a lesson in this invisibility. The most important thing in the neighborhood, the red dwarf, the star that will live the longest, the star with the potentially habitable planet, is the one we cannot see. The universe hides its secrets in the dim corners. Let us drift in the space between the Sun and Proxima. This region is known as the Oort cloud. It is a shell of trillions of icy comets that surrounds our solar system. It extends almost halfway to the next star. It is the hinterland, the border territory. Here, the gravity of the Sun is weak. The gravity of Alpha Centauri is weak. An object here could easily be stolen. A comet drifting too far could be captured by the neighbor. It is a region of slow, dark drift. Imagine floating here. Behind you, the Sun is just a bright star. Ahead of you, Alpha Centauri is just a bright star. You are equally far from both. You are in the doldrums of the galaxy. There's no time here, no day, no night, no seasons. Just the eternal starlight. From this vantage point, the 4-year lag seems short. The light from the Sun passes you. 2 years later, it reaches Proxima. You are a waypoint in the stream of history. The silence here is absolute. The concept of looking back takes on a new meaning when we consider Proxima. When we look at the Sun, we look back 8 minutes. We see the immediate past. When we look at Proxima, we look back 4 years. We see the recent past. It is a timescale that maps to human memory. You can remember 4 years ago. It is tangible. The star feels connected to our biography. But as we move further out in the next chapters, we will lose that connection. We will move to Sirius, 8 years, Vega, 25 years. We will move into the historical past, and eventually into the geological past. But Proxima keeps us grounded in the nowish. It is the bridge. There's something comforting about having a neighbor. Even if they're silent, even if they're 40 trillion kilometers away, we're not alone in this pocket of space. We are part of a local group. The Sun and Alpha Centauri are moving together through the galaxy. We are traveling companions. Like two ships sailing parallel courses in the night, separated by miles of ocean, seeing each other's lanterns. We signal to each other with our light. I am here. I am here too. The signal is delayed, but it is received. As you settle down to sleep tonight, expand your mental map. Your room is on Earth. Earth is near the Sun. But your mental neighborhood extends out to Proxima. Imagine the sphere of 4 light years. It is a huge, quiet bubble. Inside this bubble, there are only a handful of stars. It is your cosmic bedroom. Everything outside this bubble is far away. Everything inside is home. Let the red light of the dwarf star glow in your imagination. It is a night light. A dim, steady ember watching from the corner of the room. It is 4 years old, but it is warm. The distance is not a barrier, it is a blanket. It wraps us in silence. The light is traveling toward you right now. Light that left Proxima when you were 4 years younger is currently crossing the orbit of Jupiter. It will be here soon. We have traveled to the edge of the solar system, where the light is minutes old. We have jumped to the nearest star, where the light is 4 years old. These distances, while vast, are still comprehensible. They fit within the scope of a human life. We can remember 4 years ago. We can understand the scale of a single star system. But tonight, we must leave the shore of the familiar entirely. We must abandon the safety of our own galaxy and plunge into the true, terrifying depth of the cosmos. Tonight, we turn our eyes to a faint, fuzzy patch of light high in the autumn sky. To the ancients, it was a little cloud. To the Persian astronomers, it was a smudge. But to us, it is a monster. It is a city of 1 trillion suns. It is the Andromeda Galaxy. And the light that strikes your eye when you look at it has been traveling not for years, not for centuries, but for 2.5 million years. We are about to look back to a time before civilization, before language, before fire. We are about to look back to the very dawn of our species. To find Andromeda is to find a ghost in the dark. It is located in the constellation of Andromeda, the chained maiden, not far from the great square of Pegasus. If you are in a dark place, away from the light pollution of modern cities, you can see it with your naked eye. It looks like a detached piece of the Milky Way, a small, glowing oval floating in the blackness. This humble smudge holds a magnificent title. It is the most distant object that a human being can see without a telescope. Think about what that means. Your eye, a biological organ evolved to find fruit in trees and spot predators in the grass, is capable of detecting photons that have traveled for 2.5 million years. It is a testament to the sensitivity of our vision and the sheer power of the galaxy. Andromeda is our big sister. The Milky Way is a spiral galaxy roughly 100,000 light-years across. Andromeda is also a spiral, but she is larger, perhaps stretching 220,000 light-years. She contains twice as many stars as our own home. If the Milky Way is New York, Andromeda is Tokyo. Together, we dominate the local group. This is our cosmic village. It contains us, Andromeda, the smaller Triangulum galaxy, and about 50 dwarf galaxies that swarm around us like bees. Attachment, bro, attachment. But between us and Andromeda lies the intergalactic void. We spoke in the last chapter of the interstellar medium, the space between stars. That was empty. but the space between galaxies is a vacuum of a different order. Imagine leaving the Milky Way. You fly past the last outpost stars of the spiral arms. You leave the halo of globular clusters behind. You enter the deep dark. Here, the density of matter drops to less than 1 atom per cubic meter. It is the loneliest place in the universe. For 2.5 million years, the light from Andromeda has been crossing this abyss. Let us contextualize this timeline, 2.5 million years. When the light you see tonight left the stars of Andromeda, the Earth was in the Pleistocene epoch. The geography was recognizable, but different. North and South America had just joined together at the Isthmus of Panama, changing the ocean currents and triggering the ice ages. But the most profound difference was its inhabitants. There were no cities, no roads, no Homo sapiens. Our ancestors were there, in the rift valleys of Africa. They were creatures like Homo habilis, handyman. They were small, standing just over 1 meter tall. They were covered in fur. They were just beginning to experiment with striking one stone against another to create a sharp edge. The spark of humanity was just igniting. Imagine one of these ancestors looking up at the night sky from the African savanna. The sky was darker then, pristine and terrifying. They might have looked up and seen the same fuzzy patch we see tonight. The light hitting their eyes left Andromeda 2.5 million years before them. And the light hitting our eyes left Andromeda at the moment they looked up. This is the bridge. The beam of light connects us directly to the dawn of our genus. The entire history of humanity, the evolution of our brains, the migration out of Africa, the discovery of fire, the invention of agriculture, the building of the pyramids, the Industrial Revolution, the Internet. All of it has occurred while this single beam of light was crossing the silence between the two galaxies. We are a young species. We fit entirely inside the travel time of an extragalactic photon. The journey of this light is a miracle of survival. It began in the spiral arms of Andromeda. Perhaps it came from a massive blue star burning hot and fast. Or perhaps it is the combined glow of billions of yellow sun-like stars in the galactic core. The photons had to escape the dust lanes of their home galaxy. Andromeda is dusty. We see dark bands of carbon and silicate wrapping around her core. Many photons were absorbed there, lost forever. But the lucky ones escaped into the halo. Then they entered the void. For 2 million years, they traveled through absolute nothingness. No stars, no planets, just the endless expansion of space. Then, slowly, a shape appeared ahead. A spiral of light. The Milky Way. The photons entered our galaxy. They dodged the nebulas of our own spiral arms. They navigated the crowded star fields of the Orion Spur. They entered our solar system, past the gas giants, and finally struck the atmosphere of the third rock from the sun. When you look at Andromeda, you are catching the survivors of an intergalactic odyssey. And what does it look like? To the naked eye, it is gray. We cannot see color in faint objects because our eyes switch to rod vision in the dark, which is black and white. But if you use a camera, a time machine that can accumulate light, you see the truth. Andromeda is blue and gold. The core is a blazing ball of old yellow stars. The arms are dusted with the blue light of young, hot star clusters. There are knots of pink hydrogen where new stars are being born. It is a mirror of our own home. Looking at Andromeda is like looking at a selfie of the Milky Way. It shows us what we look like from the outside. But there is a twist in this tale, a secret that the light carries in its frequency. Most galaxies in the universe are moving away from us. The universe is expanding, carrying the islands of stars apart. Their light is redshifted, stretched out into longer, redder wavelengths. But Andromeda is different. When we analyze her light, we find it is blue-shifted. The waves are squashed. She is moving toward us. Gravity is stronger than expansion here. The Milky Way and Andromeda are falling toward each other. We are on a collision course. The speed is immense, 110 kilometers per second. Every hour, Andromeda gets 400,000 kilometers closer to you. Since you started reading this chapter, she has moved thousands of kilometers closer. But the distance is so vast that the crash will not happen for another 4.5 billion years. By then, our sun will be an old, swelling red giant. The Earth will be scorched. But if you could stand on a safe planet in that distant future, the view would be spectacular. Andromeda would not be a smudge. She would fill the sky. Her spiral arms would stretch across the heavens, interlocking with the band of the Milky Way. Eventually, the two cores will merge. The spiral shapes will be destroyed. We will become a single, giant, elliptical galaxy. Astronomers have already named this future island Milkomeda. The light we see tonight is the headlight of an oncoming train, but it is a very, very slow train. This adds a layer of dynamism to the view. We are looking at a partner, a dancer. The local group is a dance floor, and we are in the middle of a tango that lasts for eons. Let us return to the sensation of deep time. 2.5 million years is a geological timescale. It is the tick-tock of the ice ages. When we look at the sun, 8 minutes, we feel the rhythm of a day. When we look at Sirius, 8 years, we feel the rhythm of a human life. When we look at Andromeda, 2.5 million years, we feel the rhythm of the species. It forces us to abandon the ego. The individual does not matter on this scale, even the civilization does not matter, only the biological lineage matters. You are looking at the galaxy with the eyes of the genus Homo. It is a heritage site. There is a comfort in this insignificance. If our lives are just a flicker in the exposure time of the universe, then our problems are microscopic. Andromeda does not care about your deadline. She does not care about the traffic. She does not care about politics. She is vast, slow, and majestic. She has been watching us since we were apes. She will be watching us when we are whatever comes next. She is the ultimate long view. There's also the question of others. Andromeda contains 1 trillion stars. Even if life is incredibly rare, 1 in a billion, there could be 1,000 civilizations in that smudge. Imagine an astronomer in Andromeda. They are pointing their telescope at the Milky Way. They see a beautiful spiral galaxy. But they do not see us. They see the Milky Way as it was 2.5 million years ago. They see a galaxy where humans do not exist yet. They see a quiet, blue and gold spiral, unaware that on one tiny arm a species is waking up. We are invisible to them, and they are invisible to us. We are separated by the wall of time. We can look at each other, but we can never meet in the now. This is the tragedy and the romance of the cosmos. We are all ghosts to one another. But the light connects us. The photon that lands on your retina is a physical object that came from their home. It is a touch. As you lie in the dark, visualize the sky above you. Find the square of Pegasus in your mind. Hop 2 stars to the left, then 2 stars up. There she is, the oval light. Imagine the stream of photons pouring down from it. A gentle rain of antiquity. It is falling on your roof. It is falling on the trees. It is falling on the ocean. The earth is being bathed in the light of 2.5 million years ago. You are connected to the ancestors. Think of the Homo habilis chipping a stone tool. Think of the photon leaving the star in Andromeda. They happened at the same moment. The tool is buried in the ground. The photon is in your eye. History is not just under our feet, it is over our heads. Let the scale of it relax you. You do not need to hold the weight of the world. The universe is holding it for you. The galaxy is turning. The collision is coming, but not for eons. There is time. So much time. Drift in the intergalactic void. Float in the stream of ancient light. Sleep in the presence of the giant. We have left the comfort of our solar neighborhood. We have waved goodbye to the nearest stars, and we have even stepped beyond the boundaries of our own galaxy, the Milky Way, to gaze at our sister, spiral Andromeda. We have learned that to look out is to look back. We have peered millions of years into the past. But tonight, we are going to push the time machine to its limit. We are going to aim our telescope at the darkest, emptiest patches of the sky, places where there appear to be no stars, no nebulas, nothing but the void. And we are going to open the shutter and leave it open. We are going to stare into the abyss until the abyss reveals its secrets. Tonight, we explore the observable universe. We will discover that we are living inside a bubble of light, a sphere of history that extends for 46 billion light years in every direction. We will witness the universe expanding, stretching the light of distant galaxies until they fade into the infrared. And finally, we will hit the wall, the ultimate horizon, the moment in time where the sky becomes opaque, and we can look no further. To begin this deep dive, we must recall one of the most famous images in the history of science, the Hubble Deep Field. In 1995, astronomers made a bold decision. They pointed the Hubble Space Telescope at a tiny patch of sky near the Big Dipper. It was a patch that looked completely empty. To the naked eye, it was a blank darkness, a waste of space. They pointed the camera at this nothingness and kept it there for 10 days. They collected every single photon that trickled in from the dark. When they processed the image, the world gasped. The blank patch was not empty. It was crowded. The image contained over 3,000 galaxies. Every speck of light in that picture was not a star. It was a city of stars. Some were spirals like ours. Some were ellipses. But many were strange, blobs, fragments, train wrecks of galaxies colliding. By looking deep, we were looking back to a time when the universe was young. We were seeing galaxies in their infancy. These galaxies are billions of light years away. The light from them has been traveling for 10, 11, 12 billion years. we are looking at the cosmic toddlers. They are messy, they are chaotic, they have not yet settled into the majestic spirals of the modern universe. They are the raw materials of the cosmos, glowing with the fierce blue light of rapid star formation. This image taught us a humbling lesson. The universe is uniform. No matter where you look, if you look deep enough, there are galaxies, billions and billions of them. We are drifting in a sea of islands, but as we look at these distant islands, we notice something peculiar. Their light is wrong. Stars are supposed to be white, yellow, or blue, but the furthest galaxies look deep red. This is not because they are made of red stars, it is because of the expansion. The universe is not static, it is getting bigger. The space itself, the fabric between the galaxies, is stretching. Imagine drawing a wave on a rubber band. Now, pull the rubber band. The wave stretches out. The peaks get further apart. Light is a wave. Blue light has a short wavelength. The peaks are close together. Red light has a long wavelength. The peaks are far apart. As the light from these distant galaxies travels through the cosmos for billions of years, the space underneath it expands. The wave is physically stretched. Blue turns to green. Green turns to yellow. Yellow turns to red. This is cosmic redshift. The further away a galaxy is, the more space has stretched during the journey, and the redder it looks. We are looking at a universe that is running away from us. This creates a cosmic horizon. Eventually, the space stretches so much that the light is pushed out of the visible spectrum entirely. It becomes infrared, then microwave, then radio. The most distant objects are invisible to our eyes. They are ghosts broadcasting in heat and radio waves. To see them, we need the James Webb Space Telescope. It is an infrared time machine designed to see the invisible past. It looks at the darkness and sees the heat of the first stars. This brings us to the definition of the observable universe. The universe is 13.8 billion years old. You might think that means the observable universe is 13.8 billion light-years wide, but the universe is tricky. Because space has been expanding faster than light for much of its history, the things that were 13.8 billion light-years away are now much, much further away. They have been carried away by the flow of space. The current radius of the observable universe is roughly 46 billion light-years. Imagine a sphere centered on Earth. The radius is 46 billion light-years. Everything inside this sphere is theoretically visible. Its light has had enough time to reach us. Everything outside this sphere is the unobservable universe. It is the great beyond. There are likely more galaxies out there, more stars, more life, but we will never see them. The light they emit today will never reach us because the space between us is expanding faster than the light can travel. They are forever disconnected from our reality. This sphere creates an illusion. Because we can see 46 billion light-years in every direction, it looks like we are in the center. But we are not. If you moved to a galaxy on the edge of our sphere, you would have your own sphere. You would see us at the edge of yours. Every observer in the cosmos has their own bubble of reality. We are all trapped in our own spheres of light, overlapping but distinct. Now, let us travel to the edge of the sphere, the absolute limit. What happens if we look back as far as possible, before the galaxies, before the stars? We see a wall of fire. It surrounds us on all sides. It is uniform, it is everywhere. This is the cosmic microwave background, CMBU. To understand this, we have to go back to the beginning, the Big Bang. For the first 380,000 years of the universe, it was too hot for atoms to form. It was a plasma, a thick, glowing fog of protons and electrons. Light could not travel in this fog. It was like being inside a cloud or the interior of the sun. The photon would travel an inch and hit a particle. The universe was opaque. But then, at the 380,000-year mark, the universe expanded and cooled enough for electrons to bond with protons. Atoms formed, hydrogen, helium. Suddenly the fog cleared, the universe became transparent, and the light that was trapped in the fog was released. A flash of brilliance filled the cosmos. That flash is still traveling. We see it today, but because it has been traveling for 13.8 billion years, and because space has expanded so much, that brilliant white flash has been stretched. It has been redshifted all the way into the microwave spectrum. It is no longer light we can see. It is static. If you turn on an old analog television and tune it to a channel between stations, you see snow, black and white fuzz. About 1% of that static is a cosmic microwave background. You are watching the Big Bang on your TV. You are watching the afterglow of creation. This background radiation is a wall. We cannot see past it. It is the baby picture of the universe. When we look at the CMB, we are seeing the universe as it was, when it was just 380,000 years old. It looks incredibly smooth, but there are tiny fluctuations, tiny ripples in the density. These ripples are the seeds. Where the gas was slightly denser, gravity pulled more gas in. Over billions of years, these dense spots became galaxies. Where the gas was slightly thinner, it became the voids between galaxies. The structure of the modern universe, the web of stars and darkness, was imprinted in that first glow. It is majestic to realize that the light from that wall is hitting you right now. It is pouring down from every direction of the sky, day and night. You are constantly being bathed in the oldest light in existence. It passes through your roof. It passes through your body. It connects you to the origin. Between the wall of fire, the CMB, and the first galaxies, there is a gap. The cosmic dark ages. After the fog cleared, the universe went dark. There were no stars yet, just clouds of hydrogen gas drifting in the black. For hundreds of millions of years, nothing shone. It was the long night of the cosmos. But slowly, gravity did its work. The gas collapsed, and the first nuclear fires ignited. Let there be light. The first stars turned on. They were giants, monsters of pure hydrogen burning fast and dying young. They illuminated the fog. They re-ionized the universe. We are just beginning to see hints of these first light stars with our most powerful telescopes. They are the ancestors of everything. They forged the first heavy elements, the carbon, the oxygen, the iron. Without the dark ages and the first generation of stars, there would be no planets, no Earth, no you. Let us float in the center of our sphere. Imagine the model in your mind. You are a point. Surrounding you are the planets, light minutes. Surrounding them are the stars, light years. Surrounding them are the galaxies, millions of light years. Surrounding them are the red, primitive galaxies, billions of light years. And wrapping around the entire thing, like the shell of an egg, is the cosmic microwave background, the wall of fire, the edge of the visible. It is a closed system, a perfect sphere of information. We cannot see out. Nothing can see in past the wall. It feels claustrophobic, perhaps, to be trapped in a bubble. But it is a bubble 92 billion light-years wide. It is big enough, and it is not static. As time passes, light from further away reaches us. The horizon expands. The wall moves back. We see a little bit more of the story every day. But the expansion of space is fighting back, pushing things away. It is a cosmic tug-of-war between light trying to arrive and space trying to leave. For now, we have a beautiful view. As you rest tonight, consider the color of the universe. The sky looks black. But if your eyes could see microwaves, the sky would be bright. It would be glowing with a uniform heat. You are trying to sleep inside a glowing oven of creation. But the oven has cooled down. It is only 2.7 degrees above absolute zero. It is a cold fire. Let the concept of the sphere center you. You are the center of your observable universe. Wherever you go, the sphere moves with you. You carry your horizon. The stars arrange themselves around you. It is a subjective experience. The universe I see is slightly different from the universe you see because we are in different places. We are looking at the stars from different angles, with slightly different light travel times. But we share the wall. We share the background. We are united by the beginning. Let the static of the Big Bang be your white noise, the hum of the cosmos, the whisper of the first atoms coming together. It is a soothing sound, the sound of potential. The universe was once one thing, one hot, dense point. Now it is many things. But the light remembers the oneness. Drift in the sphere. Float in the expansion. Sleep in the center of it all. We have reached the end of our vertical journey. We have stood on the beach of Earth and watched the moon lag behind us by a second. We have floated in the warmth of the sun and felt the 8-minute gap between the fire and the skin. We have traveled to the nearby stars, witnessing the years drift by in the silence of the void, and we have plunged into the deep well of the past, gazing at galaxies that sent their light to us before our species walked the Earth. Finally, we touched the wall of the beginning, the microwave static that marks the edge of the visible. Tonight, in this final chapter, we return to where we started. We return to the room, to the bed, to the pair of eyes staring up at the ceiling. But we return changed. We no longer see the universe as a flat, static picture. We see it as a flowing river of time. We understand that the concept of now is the greatest illusion of all. Tonight, we reflect on the ghosts that surround us. We explore the profound solitude of the light cone and the equally profound connection of the cosmic web. We will discover that while we can never touch the present moment of the stars, we are woven into their history in a way that is eternal. The sky is not just a time machine, it is a memory palace, and you are the keeper of the memories. To understand our place in this temporal tapestry, we must visualize the shape of reality. Physicists use a specific diagram to map the relationship between time and space, It is called the starlight cone. Attachment. Attachment. Imagine a graph. The vertical axis is time. The horizontal plane is space. You are at the center point, the origin, the here and now. Extending downward from your position is a cone. This is your past light cone. It includes everything in the universe that could possibly have sent a signal that reaches you at this exact moment. The Sun, 8 minutes ago, is on the surface of this cone. Proxima Centauri, 4 years ago, is further down the cone. Andromeda, 2.5 million years ago, is deep, deep down. Everything you see, everything you experience comes from the surface of this past cone. But there is an area outside the cone, the elsewhere. These are the events happening now across the universe. The explosion of a star in Andromeda right now. The sunrise on Proxima b right now. These events are real. They are happening, but they are completely invisible to you. They are outside your cone. They are disconnected from your reality. You will not know about them for years or centuries or millennia. This geometry teaches us that there is no universal present. The present is a local bubble. It is a tiny island of simultaneity that extends only as far as your arm can reach. When you touch your own face, the delay is nanoseconds. For all practical purposes, you are in the present. But as soon as you look further, you slide into the past. The universe is not a single room where everyone is hanging out together. It is a collection of billions of lonely islands, sending letters in bottles across a vast, dark ocean. We are reading the letters, but we can never meet the writers, not in the now. This realization creates a sense of cosmic solitude. It means that, in a very strict physical sense, we are always alone. The Earth is alone. If a civilization in the Virgo cluster, 50 million light-years away, is looking at us right now, they do not see our cities. They do not see the Great Wall of China. They see the Eocene epoch. They see primitive mammals scurrying through the jungles of a warm Earth. We, the humans of the 21st century, do not exist for them yet. We are in their future. And they are in our future. We will not see them for 50 million years. We are ghost ships passing in the night, separated by the fog of time. But this solitude is not sad. It's protective. The speed of light limit acts as a quarantine. It prevents the chaos of the universe from overwhelming us. Imagine if gravity were instantaneous. If a black hole merged a billion light-years away and we felt the tug instantly, we would be buffeted by the gravitational winds of the entire cosmos every second. We would never know peace. But because gravity travels at the speed of light, the signals are spread out. They are diluted. They arrive as gentle ripples, gravitational waves, that we can barely detect. The delay is a buffer. It smooths out the ride. It gives us a quiet corner of the universe to evolve in. There's also a profound beauty in the idea of starlight as a ghost. When we look at the stars, we are looking at survivors. Consider the massive stars, the blue supergiants. They burn their fuel furiously and die young, exploding as supernovae after only a few million years. Many of the bright stars you see in the spiral arms of distant galaxies are already dead. They exploded thousands of years ago, but the news hasn't reached us yet. We are admiring their ghosts. We are seeing a star that is still shining, still holding its place in the constellation, even though, physically, it has been reduced to a neutron star or a black hole. The sky is a hall of mirrors that preserves the dead. Is there anything more poetic than that? To shine so brightly that your image survives your death. It speaks to the persistence of energy. Light does not decay. It stretches, it reddens, but it does not vanish. The light from a star that died before the dinosaurs is still traveling through the universe, carrying the image of its glory. And in a way, we are doing the same. You are emitting light right now, infrared light, heat. That radiation is leaving your body. It is traveling through the room. It leaks out the window. It passes through the atmosphere. It enters space. The image of you, the heat signature of your existence, is expanding into the universe at the speed of light. 1,000 years from now, a sphere of light containing the history of your life will be 1,000 light years wide. You are writing your own chapter in the history book of the sky. You are not just an observer of the time machine. You are a participant. You are broadcasting your reality to the future. Let us bring the focus back to the Earth. The illusion of now is strong here. We evolved to deal with rocks and tigers, objects that are close and slow. Our brains are hardwired to process real time. This creates anxiety. We feel that we must respond to everything instantly. The phone rings, the notification pings, the news breaks. We live in a state of hyper-immediacy. But the sky offers a cure for this anxiety. Look up. Nothing you see is urgent. Betelgeuse is not urgent, it is 600 years old. Andromeda is not urgent, it is 2 million years old. The sky is the ultimate slow media. It teaches us to wait, to process, to let things arrive in their own time. When you feel overwhelmed by the speed of modern life, remember the speed of light. It is fast, but it is not instant. Even the universe has latency. Give yourself permission to have latency. You do not need to be instant. You can take your time. Just as the light takes its time to cross the void, there is one final thought to consider, the cosmic horizon. We spoke of the observable universe as a bubble. Beyond that bubble, there are things we will never see. But knowing they are there, hidden by the speed limit, is a source of wonder. It means the mystery is preserved. We will never conquer the entire universe. We will never map every star. There will always be an unknown. In an age where every corner of the Earth is mapped by satellites, where every fact is searchable in seconds, the night sky preserves the unknown. It preserves the dark. We need the dark. We need the mystery. It allows us to dream. If we could see everything instantly, the universe would feel small. It would feel solved. But because of the time delay, because of the redshift, because of the horizon, the universe feels infinite. It feels like a place where anything is possible. So, as you close your eyes tonight, visualize the layers of time wrapping around you. The warm blanket of the sun, 8 minutes. The comforting quilt of the stars, years and centuries. The deep, heavy velvet of the galaxies, millions of years. And the white noise of the beginning, billions of years. You are swaddled in history. You are the child of the cosmos resting in the cradle of space-time. The light has finished its journey. It has landed on your eyes. It has done its work. Now you can rest. The universe will keep spinning. The photons will keep traveling. The signal will keep broadcasting. But your receiver is turning off. The time machine is powering down. You're returning to your own local time. The slow, steady rhythm of your breath. The beat of your heart. Here. Now. Sleep. Good night.